Hello, welcome to this channel, the Edisam Educators channel. This is Samuel in front of us, and welcome you to this channel. So far we've been dealing with motion. So in the previous lesson, the previous video before this one, we solved one question on motion, where we were asked to calculate the time, given some other parameters, and calculate the distance. So we want to take another example today. This is example 2, and continue with our calculation. But in case you not come in contact with the previous video, I would like you to first of all go to that one and go through that one before you come and watch this one, and make sure you get your pen and your paper and solve as we're solving. And sometimes you might need to even repeat the video if in case you don't grasp it the first time. You might need to go a second time, and it's even possible you might even have to go a third time, and to even master you might need to go up to 5 times. Okay, but you are definitely going to enjoy these lessons. So in case you need a one-on-one lesson, I'm available. Just all you need to do is just to contact me via my WhatsApp number, which is displayed up here, which is +2348038295185, in case you need a one-on-one lesson, either physically or via online medium. Okay, and you can also connect with me via my Instagram account detail, which is provided up there. So before we go ahead, if you're not subscribed to this channel, do us a favor by hitting the subscribe button, and also like the video please, and drop your comments on how we can serve you better. If you have any question relating to the lesson, drop your comments. If you have any question generally, also drop your comments. So right now we are going to commence. We are going to solve this question. So the question we have here is that a car moves from rest with an acceleration of 0.2 meters per second square. The car started from rest. Starting from rest means that it was stationary, it wasn't moving. That means that the original velocity, which is the initial velocity at rest, is 0 meters per second. So we are told to find its velocity. This is going to be the final velocity if it has moved a distance of 50 meters. Also find the time taken to cover this distance. So our solution is going to be, let's go ahead and solve. Our solution is going to be a car moved from rest with an acceleration. So let's write out the parameters we have, the quantities we have. We have acceleration A is equals to 0.2 meters per second square. Okay, we have the initial velocity because it started from rest. U is equals to 0 meters per second. Then find its velocity. Final velocity is not given. That is a question mark there. If it has moved a distance of 50 meters, S distance is 50 meters. So which equation we will be using here? So let me start from the first equation of motion, although I just want to bring it into play. So the first equation of motion is that V is equals to U plus AT. That is the first equation of motion. The V is equals to what? U plus AT. In this equation now, we have to find V. So this question, it has V. U was applied, that is from rest. The body was moving from rest. A was supplied. Acceleration was supplied, A. Then T wasn't supplied. So we can't make use of this equation. Okay. So let's move to the next one. S is equals to ut plus half a t squared. Over here, we have S. We have to find V, final velocity, which is not available in this equation. So let's not even waste our time. We have to find what? The final velocity. So we can't get that with this equation. But we were also asked to find time taken to cover the distance. This equation, let's see whether it can help us. This equation can't even help us to find the distance, but this equation 2. Let's see whether equation 2 can help us to get the distance. Let's see. This is distance S. U is initial velocity, it's given. T is the time, not given. T was not given, so we can't use it to even get the distance. Okay, so let's go to equation 3. In equation 3, we have V square is equals to U square plus 2AS. We were asked to find velocity. Find the velocity if it has moved a distance. This is the final velocity. We have to find the velocity, which is the final velocity actually, because there was an initial one from rest. Then we have initial velocity, which is at rest, 0 meters per second. Acceleration in this question is supply. Distance is supply. So we can conveniently use this equation here to arrive at our answer. We can conveniently use this equation 3 to calculate for V, the velocity. So let's go ahead. So V square is equals to U square. U is 0, so 0 square plus 2AS means 2 times A. This means 2 times A times S. So 2 times A, which is our acceleration is 0.2 meters per second square, times the distance here, S, which is in this case is 50 meters. Okay, let me attach the units here. 0 meters per second square. So 0 raised to power 0, which is 0 times 0, this is 0, plus 2 times 0.2 times 50. 2 times 50, let's start from there, gives us 100. So 100 times 0.2, what do we have? This will give us 20. How is it 20? If you punch your calculator, you are going to get 20. But how? If parametric, we don't want to use a calculator. We just want to do it manually with our brain. So this 0 plus whatever is here, this 0 will not add anything. So let's just forget about it and deal with this side. So this discard is 0. 0 will not add any value. It will not increase this value. It will not add anything. When you add something with 0, the value remains unaltered. So let's just go directly to V square is equals to 100 times 0.2. So like I said that, how I said it's 20, that how did we get 20? So what you're going to do here is that just you have 100 has 2 zeros. So make sure this part has up to 2 decimal place. What it has is 1 decimal place. So add another 0. 0.20 and 0.2 are the same number. This 0 I'm adding doesn't alter this value. It's 0.2 and 0.20 are the same thing. Take note, please, if you're not aware of that. 0.2 and 0.20 are the same thing. So now multiply by 100. In 100 we have 2 zeros. So just come to the decimal and move the point to the right. 1 0, the second 0. moves it out. So what do you have? You have 0, 20. The 0 in front is useless, so just put 20. So that was how I got 20. If you punch your calculator, you will discover that you get 20. But if you want to do it manually, just follow this explanation I've just explained. Okay. Make sure that after the decimal you have 2 digits. Right now we have 1, which is 0.2. So if I must actually add a digit, and the only digit I can add without increasing the value is 0. So I add 0. I now move the decimal 2 places based on the zeros in the 100. So we have 1, 2. If this was 10, I would have just moved the decimal 1 places. That means there would have been no need to add a 0. I would have just 0.2, move the decimal outside, and that would be 2. If it was 0.2 times 10, it would have been just 2. So our answer here is 20. V square equals to 20. Now, V square is equals to 20. But we are not looking for V square, we are looking for V. So we have to find the square root of 20 to get V. So square root of V square is equals to square root of 20. Square root of V square is V. Square root of 20 is going to be 4 point. Let me make use of calculator. Let me make use of calculator. This is 4.47 meters per second. This is to 2 decimal place. 4.47 meters per second. So this is what I got for the velocity. Okay. Now, before I go ahead, we make use of the third equation. Will it have been possible to make use of the fourth equation? No. The fourth equation, if you try it out, you discover that you can't use the fourth equation. The fourth equation is that S is equals to U plus V all over 2 times T. We have U, we have V, we have S, but we don't have T. Sorry, we have U, we have S, we are looking for V, but we don't have T. So we can't use it. So the next part of the question says, find the time taken to cover this distance. Find the time taken to cover the distance. So we can go back to any of the equation now. We have every parameter. Formerly there was no final velocity. Every other thing was available apart from. So right now we've gotten the final velocity. We have initial velocity. We have acceleration. We can now find time with any of the equation that involves time. So let's go back to equation 1. Let's go back to equation 1. So from equation 1, we have that V is equals to U plus AT. Our V here has been calculated as 4.47 meters per second. Our U, initial velocity, was 0 meters per second because the body started from rest. AT means A times T. Acceleration is what? 0.2 meters per second square. Our time, we don't know. The time involved in this journey, we don't know. So, at the end of the day, this 0 adding to this side will add nothing. So we discard it, forget about that 0. We deal with this. 0.2 times T is 0.2 T. 4.47 is equals to 0.2 T. So how do we solve? 4.47 is equals to 0.2 T. So we solve for t. We divide both sides by 0.2 to solve for t. So 0.2 has to leave. You say 0.2t divided by 0.2t, 0.2 sorry, is equals to 4.47 divided by 0.2. 0.2 cancels 0.2. So you can punch your calculator to get this value, but not everything that you have to depend on calculator. Don't become calculator dependent. Try to use your own initiative. Try to reason things out logically. So yeah, how do we solve this stuff here? How? You can just say this is 4.47, this is 0.2. So just come down here, 4.47 over 0.2. Move out the decimal point. Move it out. Move this one out. So this gives you 444.7 all over 2. So it is very much easier now to divide. So if you have 44.7 divided by 2, let me just do it here because I have some, at least the space here is bigger. So you have 44.7 divided by 2. 44.7 divided by 2. 2 here, 1. 2 in 4 is what? 2. 2 in 4 is what? 2. Just add a 0 here because there will be a remainder. 2 in 7 is 3. The 0 I'm adding has not altered the value. This 0 I'm adding because it's after the decimal. It has not altered the value. So 2 in 7 is 3, remainder 1. Making this 0 now 10. 2 in 10 is 5. So what do we have? We have 22.35. So our t, which we're solving for, our t is equals to 22.35 second. 22.35 seconds to 2 decimal place. If it's to 1 decimal place, this is going to give us 22.4 seconds. Okay. So you can use any of those equations, any of them. You can apply equation 2, you still get your t, the same t. You can apply equation 4, you are still going to end up with this same t, 22.35 seconds to 2 decimal place, or 22.4 seconds to 1 decimal place. Okay, so this is your final answer. This is what? Your final answer. So thus far we've treated 2 examples. Thus far we've treated what? 2 examples when it comes to velocity acceleration problems. Okay, we've treated 2 examples. So just watch out for the next video and we'll still treat another example. We've not treated a problem yet where we are asked to calculate acceleration, but it's the same process. Once you can always just understand how to, as in, make something the subject of an equation. So always have the 4 equations at your fingertips. If you try, write out, the first step is that write out all the parameters you have. Write the one you are looking for. Bring the first equation, look at it. Does it have what I'm looking for? If it doesn't have what I'm looking for, just discard it. If what you're looking for is V and it doesn't have it, just trash it out. Go to the second one. If it has what you're looking for but doesn't have it has something that was not supplied, then no point of using it. So you try them and you know what to use. This thing comes by practice, you understand? It's not automatic. But when you just practice, you're going to get accustomed to solving these problems. Okay, so we are going to meet in the next video. Okay, we're still going to solve more questions in our next video. This was example 2, so we're going to move on to example 3. There are questions that involves acceleration and deceleration. So So we will still look at such. There are other questions that are not so straightforward. These questions so far we've been dealing with are more or less, they are straightforward. So we will still go to other questions that are not as straightforward as this. Thank you so much for giving your time, sparing your time to join us. So I want to appeal to you that if you're not subscribed to this channel, make sure to hit the subscribe button and click on the bell icon so that you will always be notified whenever we upload a new video. Click on the bell icon, set it to all, and then hit the like button as well and drop your comment. Thank you very much. Bye, and watch out for the next video, and share the video with your friends and families and others as well so that they can also benefit. Thank you so much.